Assalamualaikum and hi everyone. Our group will be presenting about microwave in cooking. What's actually microwave in cooking? So let us dive in the information. Our member consists of 5: Anis, Adlina, Adlin, Husna and lastly Amira. First, for the introduction, microwave are a type of electromagnetic wave that we use every day to cook food quickly and efficiently. Unlike regular oven that heat food from the outside, microwave pass through the food and make water molecule inside move rapidly. This movement produces heat, cooking the food from the inside out. The microwave oven creates this wave using a device called a magnetron. The wave bounces around inside the metal oven, heating the food evenly. This process is a fascinating example of how wave and energy work together in real life. Understanding microwave helps us see the connection between physics and everyday technology.
Hi, I am Nur Adina and I will be explaining how microwave work based on wave physics. Microwaves are actually electromagnetic waves, just like light or X-ray, but they have a longer wavelength. Microwave oven use a specific frequency of 2.45 GHz, which is around 12 cm in wavelength. This frequency is perfect for interacting with water molecules in food. Now let's talk about what actually happens inside the oven. This diagram shows how microwave bounce around inside the metal cavity and heat the food from multiple directions. The key idea is this: microwave don't heat the plate, they heat the water molecules in the food. These water molecules are polar, meaning they have a slightly positive and negative end. So when the electric field of the microwave changes direction about 2.45 million times per second, it forces the molecule to flip back and forth. This rapid movement causes friction between molecules, and friction produces heat. That's how your foods get warm from the inside out. Let's talk about why microwaving can feel inconsistent. When microwave bounce off the metal wall inside the oven, they create something called standing wave, like when you plug a guitar string and it vibrates in fixed pattern. In the oven, this pattern have antinode where energy is higher and node where it's almost zero. That's why part of your food can be piping hot while other parts stay cold. The spinning turntable helps by moving the food through these hot and cold zones, making the heating more even.
Okay, next is real life demonstration. First, let's rise in the microwave. The moment the microwave is turned on, the magnetron emits microwave 2.45 GHz inside the oven. These microwaves bounce around the oven, penetrate the food from all sides. Second is rice starts to heat up. The rice contains water molecules trapped inside the grains. Microwave are electromagnetic wave that make this water molecule vibrate very fast. This vibration causes friction, which generates thermal energy, that is heat. Lastly, heat spreads through rice. The heat first forms where water molecules are more active, then spread through conduction to the rest of the food. If rice is lump, the center may remain cold, showing that microwave penetration is limited and heat still needs time to travel inward. The next is scientific principles demonstrate in real life. First, we see energy conversion happening. The microwave oven changes electrical energy into microwave radiation. Then those microwave go into the rice and get absorbed by water molecules. This makes the molecule vibrate, and that vibration creates heat. That's how your food gets hot. Second, this shows selective heating. Microwave mainly heat parts of the food that contain water. That's why rice or soup get hot fast, but dry food like bread and can turn hard or burn to stick. Third, if you don't stir the rice on the microwave, doesn't have to turnable, you will notice some parts are hotter than others. This is because of standing wave inside the oven. They create hot spots and cold spots, which show how wave interference works in real life. So basically, a simple task like reheating rice actually show multiple physics concepts from molecular vibration to wave interference right in our kitchen.
Next, we will move to the advantage of the microwave for cooking. There are several key advantages of using microwave for cooking. Firstly, the heating process is rapid. Because the energy is deposited directly into the water molecules, cooking is much faster than with conventional ovens. Secondly, it's energy efficient. Unlike conventional ovens that heat the entire chamber, microwave ovens mostly heat the food, reducing the energy loss. Thirdly, the microwave selectively heat polar substance. So, materials like glass or certain plastics don't absorb much energy. This makes the process safer and more targeted. And finally, The microwave can penetrate a few centimeters into the food, which helps the interior more directly than surface-only methods like pan frying. However, there are also some limitations, mostly due to the physics of wave behavior. One of the issues is non-uniform heating. Inside the microwave cavity, standing waves form due to reflections leading to interference patterns. This creates hot and cold spots, which is why a rotating plate is often used to help distribute energy more evenly. Secondly, the microwave also can't brown or freeze food effectively because the air inside the oven isn't heated and the surface temperatures remain low. This means no melt-like reaction unless additional grilling elements are included. Another issue is limited penetration depth. Microwaves can only penetrate so far into dense or dry food, meaning their inner portion often still rely on conventional heat conduction. Also, not all containers are microwave safe. Metal reflects microwave and some plastic can melt or release harmful chemicals. Last but not least, non-polar substances like oil or very dry food don't absorb microwave energy well, leading to uneven or insufficient heating.
Now, let's move to the application of microwave for cooking that impact our daily life. The first is reheating. Microwaves are truly excellent for quickly warming up leftover food without altering their texture or flavor, unlike a conventional oven and stovetop. This microwave ability to heat uniformly and repeatedly makes it an useful tool for busy individual and family. It works by causing water molecules within food to vibrate and generating heat, which is why food with higher water content reheat particularly well. Next is defrosting. Microwave efficiently defrost frozen food and saving available time, especially when you forget to take out something from freezer in advance. Most microwaves have a defrost setting, and it helps to maintain the food quality and preventing bacterial growth that can occur if the food is thrown at a room temperature for too long. And next is baking. Certain microwave models can come with a baking function and enabling quick baking of cake, cookies, and bread. A microwave baking function can be conventional alternative, and especially in a smaller kitchen or dorms room where the full oven isn't an option. Next is steaming. Steaming is another excellent function of microwave. Microwave can effectively steam vegetable, feed, and fish, which is a fantastic way to preserve their nutrients and natural flavor. Unlike boiling, which can leach nutrients into the water. Microwave also allow the food to cook on its own moisture or with a small amount of added liquid, which results in a healthier way. Next is melting and softening. Microwave can melt butter, chocolate, or cheese. It also perfect to softening your ice cream or butter to reach a respectable consistency. And lastly, beyond other function of microwave can actually be used to cook a very wide variety of dishes. These include vegetables, rice, pasta, and even some meats. And it's significantly reducing cooking duration compared to the traditional methods. And furthermore, it also often reduce the need for multiple cooking utensils and simplifying can clean up, which is a huge plus for anyone that looking for a convenience in their kitchen.
In conclusion, the microwave oven is a remarkable example of how physics integrates in our daily life. By using electromagnetic wave at 2.5 GHz, microwave can rapidly heat food by exciting water molecules, converting energy efficiently from wave form to thermal energy. This allows food to be cooked faster than conventional methods, with benefits such as energy efficiency, selective heating, and convenience. However, microwave also come with limitations such as uneven heating, limited penetration depth, and restriction on material use. Despite these limitations, microwave have become an essential tool for reheating, defrosting, cooking, steaming, and melting food items, proving they are practically in modern kitchen. By understanding the scientific principles behind microwave cooking, we can better appreciate how physics makes our daily routine more efficient, safe, and